So let's say we had something like this. And we are trying to fit a line that has least error. Line with least error. That is called regression line. We also call the line of best fit. Line of best fit. So the line that, not this line, but the line that has the least error. What does that mean? These distances from the actual points to the line are the smallest possible. All these distances are the smallest. In other words, the least error possible. And this is called the regression line. And this is the line that you see in red in StatCrunch. And of course, it's a line, so we're going to look at y equals mx plus b. And we're going to copy it right now. So this, if you remember, this is the slope-intercept form. Of an equation of a line. Can we determine that? Very easily with a calculator and with StatCrunch. And it will give us the entire line. Everything. The slope and the y-intercept. So let's do this first with a calculator because we already have the data. So go to Stats, go now to Calc. If you fall behind, please let me know and I'll stop and I'll present again. So go to Calc and scroll down to number 4, linear regression, ax plus b. So in the calculator, in TI-84, a is the slope and b is the y-intercept. Same thing with b here. But A is the slope is denoted by A. Okay, so let's click on number 4, linear regression, press enter. The lists have to be exactly where you have X and Y. In my lists, I forgot. I forgot where I think my lists are in 10 and 11. I'm pretty sure, but I'm going to double check. So yes, my information is X is in my L10. And 11 and y is in my L11. So you will have probably L1 comma L2, but I will have L10 comma L11. So we want to calc, we want to choose 4, and I have L10 and I have L11. Now stop before you continue. Oh, I forgot one thing. Let's start from scratch because you may not have this and I do have it. So first of all, let's go to second and catalog. You don't have to do this twice. This is done only once. So second key, whatever you have, blue, yellow, whatever, and catalog which is 0. And please scroll down to diagnostic on. And select that twice, I think. I don't have to do it because I've done it already. So scroll down, scroll down. You can also put D and it will jump to D, but it's not that far. It's up to you. But anyway, find the diagnostic on. Diagnostic on. Press enter and enter again. So diagnostic on. Because if you don't do this one time, you can turn it off if you want later. But if you don't do this just one, all you need is once, you will not see what everyone else will see. So that's why we need a diagnostic on. Press enter, enter. And now we are ready to go back and determine the linear regression line. The equation of that line that has best fit. The least error. Okay, assuming you've done that, are you okay? Is everyone okay? Yes?
Yes.
Okay, very good. So finally, let's go to stat. And we want to do the linear regression. And stop, don't do anything. When you get to store regression equation, so scroll to that point. Press on variables now. When your cursor is blinking here at the store regression equation, because we don't want to copy it. The calculator will store it for us. Press on variables. Go now to Y variables, not to statistics, to Y variables. Select function. You can select any function you want. I'm going to select Y1 and press enter. See what just happened? So I have my lists. I have stored the regression line that the calculator will calculate for us in variable Y1, and then I click on calculate and press enter. And look at what I obtained. I obtained A, which is 3.166. So Y equals 3.166102 x minus 55.7966. This is the linear regression line with the slope y-intercept. And look what else we obtained. Here it is. 0.9386958. Any questions? Okay, now at this moment we're going to use that table that I showed you in modules.
Question.
Yes, please. Any questions? Anything? It gives me a second to get some water.
I was wondering what the difference was between like the linear regression line and the correlation coefficient. Does the correlation coefficient have a line with it too? No, right?
No. Very good question. The correlation coefficient is just a number. It's not a line. It cannot be graphed. It's just a number. The correlation coefficient tells us whether the relationship is positive or negative. It tells us if it's strong negative, strong positive, or close to zero, no linear relation. But the line of best fit, which is the linear regression, very good question. I'm going to write down what it does. Since you asked now, I'm going to answer now. Y in our case, Y equals, I'm going to just copy that one, 3.166102x minus 55.7966 is the linear regression line that helps us predict Y values for X values that do not exist in the data set. That do not exist in the data set. Or exist. Or we can also check. Or check with existing ones to find the error. That error will be called residual. I didn't get to that yet, but since you asked, so we can predict. We can predict. Note, and I think I put it somewhere in your notes. Note, we do not predict for x values outside of the data set. So for example, see here the minimum is 99. If you want me to use the linear regression line to predict for 80, I will say no. Because 80 is not within the range of the data. If you ask me to predict for x equals 200, I'll say no. Because I don't know what happens outside of this. So for this data set, you can ask me to predict if you want anything from 99 to 105. So the range, 99 through 105. But if you say predict for x equals 80, I will say no, miles per hour. If you say predict for x equals 200 miles per hour, or 110, or 115, I'll say no. If you want me to predict for 102, I can tell you what the result is for the data set. If you want me to predict anything else in between, 99 and 105, I can use the data set. But if you want outside of the range, I'll say no. I cannot use this because I don't know what happens outside of the range. We only discussed this range. Okay, so I wanted to, is this okay, Lee? Yes? Okay, perfect. Okay, so now let's go to that table 2. So for table 2, first of all, we have a sample size of 8, lowercase n, 8 entries. Our R that we calculated, it took us a while because it's a long calculation. Okay, so let's look for n equals 8 in the data set. R is a positive number, otherwise I will have determined the absolute value. So I have to determine the absolute value, but since this is positive, it's the same number. So let me share my screen again. I'm sharing. Go to, where is my class? Right here. Okay, so going to modules, and we go to the list of tables and formulas. Scroll down, I think it was page 5. Okay, and for n equals 8, as you see, it's somewhat limited between 3 and 30, right? Because for a higher number of entries, it will be more obvious. But for smaller number of entries, if we want to check indeed whether it's a linear relation, we should look at 8, entry 8. The correlation coefficient gives us a critical value. This is the critical value. I'm going to write that down. 0.707. So critical value, R critical value 0.707. I'm going to stop sharing before I forget, because this number, R, is bigger than the one that we determined. Because this number is bigger than the critical value. Critical value. We conclude, based on the table, we conclude that it's definitely a linear relationship. So that's what I wrote on page 3 at the very bottom, or midway. Compute R, determine the absolute value, find the corresponding critical value in table 2 for n equals 8. Is the value of R greater than the critical value? If it is, then it's a linear relationship, and it is. Any questions on this? Any questions so far? Any questions? Before we look at, finally, at 4.2, which is the least squares regression, I I just put a little note in here, explain the difference between correlation and causation. So, as discussed in Chapter 1, an observational study cannot show that there is a cause, even if we conclude that there is a correlation between two variables. So, I was giving you at the very beginning a simple example with, I forgot where it was, with, let's say, number of cigarettes and blood pressure. We cannot conclude that the number of cigarettes smoked by a person will definitely cause higher blood pressure or lower blood pressure. So we remember that there is what we call a lurking variable that can influence the relationship. It confounds, we say, the results, like body mass index and height and smoking. There was just any other variable, alcohol consumption, etc. So there may be lurking variables, so we cannot conclude that this is that smoking X number of cigarettes per day creates high blood pressure. Okay, finally we get to analyze this line that we talked. It's called the least squares regression line, to be exact. So least error, least squares. So this is 4.2, what is called least. You already seen it. You know what we're going to talk about, but we have more details about it. Least squares. Yes?
Clarify. So we use technology to find the regression line, but now we're going to learn how to do the regression line manually, right?
Yes. So you're not going to have to. You're talking about all these calculations that we did.
I was just wondering if we already learned how to figure out the regression line manually, like the equation for the regression line manually.
We can, yes. We're going to get to identify how we determine each and every, how we determine the slope and the y-intercept, yes. So we have a formula for this and we have a formula for that. Yes, we're going to, as I said, these are the details that I didn't get the chance to explain yet. So we have a formula for this, we have a formula for this, and we're going to talk about the residuals, the error. Because there is always going to be error. The line will not pass, may pass to a few of them, but not all of them. So there is always going to be error. Very good question. Anything else? Anyone? Okay. So let's go back to